Okay, so my x values here are a and b, and my y values then be f of a, f of b. If I were to find the average rate of change between these two, I'm just going to show you symbolically, what I would have would be my change in y, f of b minus f of a, over my change in my x's, b minus a. Symbolically, you might see this represented for average rate of change or slope. I'm going to add one more little piece in here. Let's do another graph. I'll work our way up into this problem. We have another graph. I'm going to look at this point and this point again. This point on the x-axis, I'm going to actually label x. And then, then I'm going to go this distance. I'm going to call that distance h. I'm going to go a distance of h across the x-axis to a new point. Now the way I get to that new point is I take my x and I add my h. So that new point is x plus h. My y values for these, like we did on the last one, this is represented as f of x. And this point is f of x plus h. So in order to find the slope or the average rate of change between the two, I would take my change in my y values over the change in my x values. Now I'm going to make this a little simplified here because the change I already know is this distance right here. It's h. So this is another representation for our average rate of change. And this representation you're going to probably get a lot more familiar with, but this is known as the difference quotient. And as you continue on in mathematics, and especially calculus, this is something that's going to come up over and over and over again. The difference quotient. Don't get scared by all the symbols or the fancy name. The difference quotient is our average rate of change. It's our slope, in essence, of the straight line between those 2 points. Now, how we deal with that algebraically, let's go through a few examples here of finding the difference quotient using some of our algebra. So, example 1. We'll take a few of these so you can get a little more comfortable with it and working with our difference quotient. Example number 1, we're going to take a function, and we'll start with a fairly simple one to begin with. Let's just take 8x minus 3. And what I'm going to be doing is, like I said, finding the difference quotient. So I need a couple of pieces. I need to know f of x plus h, because I need a value or an expression that I'm going to put in here for that piece. And I need the f of x. Well, I already have f of x right there, so let's see if we can figure out f of x plus h. Function notation. That means this stuff is what's going to get plugged into my equation for x. So 8, this goes in place of the x. And now I'll simplify that. Okay, so I have my 2 pieces that I need for the difference quotient. I have my f of x and I have my f of x plus h. So let's take those pieces now and put it into our difference quotient of f of x plus h. minus f of x all over h. Okay, my f of x plus h I found was 8x plus 8h minus 3. That's the first piece of information I had. Then I'm going to subtract my f of x, this piece. Now you notice I put them in parentheses so I can see easier what's the first set and what's the second set of information, because I have to subtract all of this. Okay, all of that over h. So now I will simplify this. I have 8x minus 8x. Those guys are gone. 8h, I've got nothing else there, so I'll put the 8h down again. Then a negative 3, so I have minus 3 minus a negative 3. Don't get messed up on your signs here. Minus the negative means I'm adding that. So negative 3 plus 3, those guys are gone. All over h. Simplify the next step, and I get to 8. Which is exactly what you should have known to begin with, because if we're talking about slope and the difference quotient is finding slope, or average rate of change, when you look at this equation, you should have known it was a linear equation and your slope was 8. So you can check yourself pretty easily there. There it is. Now, let's try one that's a little more involved. Okay, let's go to a slightly more complicated problem here. And let's work with a function. It's quadratic. Let's do 2x squared plus x. What we want to find is the difference quotient. Okay? All right, so remember we need two things to work with for our difference quotient. Let's go back and look at this again. Our difference quotient, I need my f of x plus h and an f of x. Have the f of x. What I've got to find now is my f of x plus h. Okay, so I'm going to take this x plus h and I'm going to plug it in everywhere I see an x. So I have 2 times x plus h squared plus x plus h. All right, let's simplify this. X plus h squared, remember, is x plus h times x plus h. We're going to be multiplying that out. It's a perfect square here. So x squared plus 2xh plus h squared. Distribute 2x squared plus 4xh plus h squared plus an x plus an h. Okay, I'm going to check. I guess there's nothing there that I can combine. So now I have my f of x and my f of x plus h, and I'm going to put it into my difference quotient. Okay, so I'm going to take all of this stuff. We have 2x squared plus 4xh plus h squared plus x plus h. And then I'm going to subtract all of this stuff. All divided by h. Now we simplify. As we simplify this, 2x squared minus the 2x squared, I have an x minus the x, and I'm left with all of this Now, some of you, and I know you'll do this, are just going to take a pen and slash the H's and say you're done. Do not do that. Okay? You cannot cancel that way. These things are all attached up here. You can't just wipe out one guy. He's attached to all the rest of them. In order to do our canceling, I'm going to factor out an H. You got to take an H out of every little piece that goes across there. Now that he's multiplied times that stuff, I can cancel. Okay? So my difference quotient looks like this. Now, I want you to keep in mind what we had here was a 2x squared plus x. You should know that that means that, we don't even need to graph them, just in general. Let's come over here and look. We have a parabola. Okay? If I ask you to tell me the slope anywhere along the parabola, hopefully you'd be able to tell me that the slope is changing as we go across. Over here I've got a negative slope that's steep. Right here I've got positive slope that's not so steep. It changes depending on what interval I'm looking at. It changes depending on what my x values are. So what this difference quotient has done for me here on an equation like this is it's given me another little expression there that I can use to find the slope, or the average rate of change, over any interval I choose. I can choose any interval I want, and this will help me find it. Okay? Difference quotients. All right, so at this point, your teacher will have an assignment for you going over our difference quotients. Let's see, what else have we talked about? Average rate of change and some of our important points on our graph. Good luck with your assignment today.